Well, here we are, doing some more graphing. We're going to talk about parallel and perpendicular lines. Particularly, we're going to try to draw these lines that have a given point on the line and the slope given to us. We just have to sketch it out. So, for example, this one has slope 3, passes through the point 1 minus 1. So first we find 1 minus 1. X is 1, y is, here we are. And then we have to create slope 3. So we want to go over 1, up 3, or back 1, down 3, and then create a line like that that has the given slope. Not too bad. Judging from how this looks, over 1, down 3, here's the y-intercept. X is 0, y is minus 4. So we actually got some information off of that. We'll try it again over here. The point is minus 2 for x, 1 for y. Here it is. Now I need a slope of minus 1/2. So we can get that minus 1 delta y over delta x. Y goes down 2 if x increases by, y goes down 1 if x increases by 2. So over 2, down 1, here we go. Over 2, down 1, like that. Over 2 more, down 1 more, there we go. And then go ahead and join those up to make a line. So we get a pretty good idea of what the line looks like if we know a point that it passes through, and then we know what the slope is, and we make an accurate graph. Sort of hard to do by hand, but if you're just interested roughly of what's going on, then we're okay. We even actually can tell here that it passes through the origin. More discussion. Parallel lines. Parallel lines have the same slope. That kind of makes sense. So here is a line of slope 3. Anything parallel to it, so parallel means they don't cross, they have the same steepness, and slope is measuring steepness. So if that had slope 3, then a parallel line has to have the same slope, because basically you could pick similar points and get the same change in y and change in x. It'd just look like just moving that whole line over and just translating it over. So that makes sense. Either the same value, here is slope 3, or maybe both are undefined. So that would just be if they're vertical and parallel. Yeah. So every line has a slope except for vertical lines. And so the only way the slope could be undefined is if the line's vertical. So if you have two lines with undefined slope, those two lines have to be parallel or possibly the same line. You might not notice that. And parallel lines have the same slope. If they have the same slope, they're parallel or maybe the same line. Okay. And then we talk about perpendicular lines. Perpendicular means they meet at a right angle. Now, what does that mean? It means something like the corner of your paper, right? So this is one side, and that's the other side of a traditional piece of paper where it's a 90-degree angle, or where streets cross. They usually can cross at a 90-degree angle. So perpendicularity is that 90-degree-ness of the angle between the two lines. So if it's horizontal and vertical, that's a 90-degree angle. So horizontal and vertical lines are perpendicular. So it's easy to tell that. One has slope 0, one has slope that's not defined. They're perpendicular. Otherwise, we have an interesting equation that says lines are perpendicular if the product of their slopes is minus 1. Or M2 could be minus 1 over M1, like that. So if we wanted to make a list of perpendicular, that's the notation of perpendicular slopes, 3 minus 1/3. So one's the negative reciprocal of the other. 2/3 minus 3/2. 1 is minus, but, or you just take the product is equal to minus 1. Minus 1/5, 5, all good choices for our perpendicular slopes. And we'll have a little bit of a discussion on the next slide. Can you see why that should be true? You can use it without knowing why, but it's more fun when you do math, have an idea why things hold. And it also helps you remember exactly what the relationship is if you know a way of thinking about it that what you can remember. So we'll talk about why the product of slopes should be minus 1 if lines are perpendicular in just a minute.